Hello children, another interesting example where you will have multiple links. Okay, that means one is connected to the second is connected to the third, like that. You have to establish multiple links. These types of examples to develop your analytical ability. How will you analyze the situation? Okay, let us start. You are given that in this figure, these two lines, line DE and GF, they are parallel. Ray EG bisects this angle, that is DEF, and ray FG bisects angle DFM. We have to prove this result and this result. Okay? DEG, I have numbered that angle as angle number 1. Okay? Angle 1 is half of angle EDF. That means we have to prove that, according to the numbers which I have written, we have to prove that angle 1 is half of angle 5. Angle 1 is half of angle 5. Okay? Let us start. Here I have written angle 1 is half of this angle. Why? Because this is the angle bisected. So angle 1 is half of angle 2. Angle 1 is half of angle 2. Ray EG bisects the angle. Correct. Okay. Now, but line DE is parallel to GF, that is given. So angle 2 will be congruent to angle 3 because these are corresponding angles. If I draw, just to explain, if I draw the figure separately, these are the two angles. This is angle 2, this is angle 3. And these two lines are parallel, therefore angle 2 and angle 3 are equal, corresponding angles. We have written it because they are corresponding angles. But now we have written 2 is equal to 3. But 3 is equal to 4. That has been already given because this is the angle bisector. So we have written 3, angle 3 is equal to 4. Ray FG bisects angle DF. And angle 4 will be equal to angle 5. This is angle 4. This will be equal to angle 5 because these are alternate angles. So that also we have written. So you are getting a link like this. Angle 2 is equal to 3. 3 is here. So 3 is equal to 4 and 4 is equal to 5. Therefore by transitivity 2 is equal to 5. So we have written from 2, 3 and 4, from equation 2, 3 and 4, angle 2 is equal to angle 5. Okay, angle 2 is equal to angle 5. So now we are going to replace angle 2 by angle 5. So in equation number 1, wherever angle 2 is there, I replace it by angle 5. So what I get? Angle 1 is half of angle 5. And angle 1 is half of angle 5. This is what we had to prove. Only we have to express it in terms of the names of the vertices. And therefore, this angle is half of this angle. That is angle DEG. Angle DEG is half of angle EDF. So first part is proved. This is complicated. Children don't analyze the situation because they have not been exposed to this type of situation in the lower classes, and therefore what happens that if they see a problem like this and if they are not able to establish the links, immediately they will stop thinking. That is not correct. Okay, these are the examples which lead you to analytical thinking. Okay. Now there is one more question. EF is equal to FG. EF is equal to FG. Like that, there are some more results which can be proven using this figure. Now, angle 6 is this smaller angle, this angle. Angle 6 is equal to angle 1 because this is the angle bisector. And angle 1 is equal to angle 7. Angle 1, this is the angle 1, this is equal to angle 7 because these two are alternate angles. These two are alternate angles. So angle 6 is equal to angle 1 and angle 1 is equal to angle 7. 6 is equal to 1, 1 is equal to 7, that means 6 is equal to 7. So 6 is equal to 7. And there is a theorem called as converse of isosceles triangle theorem, which says that if in any triangle, two angles are congruent, then the opposite sides are congruent. So if these two angles, 6 and 7, they are congruent, this is the figure, okay? This is 6, this is 7. These two angles are congruent, so their opposite sides, this, its opposite side is, they are also congruent, and therefore EF is equal to FG. Unfortunately, the theorem of converse of isosceles triangle theorem, that has been given after this problem. So in that case, it becomes difficult to explain to the children. Otherwise, we will have to write the proof of isosceles triangle theorem in this figure using the construction and then prove the second result. Okay, but this is the logical way of going ahead. Thank you, children.